Assalamu alaikum students, welcome to JEE Mains and Advanced Academy. Today onwards we are going to start the major portion of the physics, that's kinematics, which will be almost completing the 50 to 55% of the total syllabus of JEE Mains and Advanced. So our first topic will be mechanics. So first of all, we'll see what mechanics is. Mechanics simply means the study of motion of bodies or particles. So if we are discussing the motion of the bodies, that's called as classical mechanics. If we are discussing the motion of the particles, that's called as quantum mechanics. This mechanics is subcategorized into kinematics and dynamics. As we all know, mechanics is the study of motion. So first of all, we'll see what kinematics means. I'm breaking the kinematics into the two words, that's kina and matics. Kina simply means motion, and the matics means the calculations, or I can say the mathematics related to motion. As you all know, this motion is simply time rate of change of position. When the position of the body will change, we can say the body is in motion. Okay. Now the position, we have to see the change in position. First of all, if I'm telling you that this is my body, any object or body, now I have to locate this body where it is. We have to use the reference system for this. From today onwards, you will remember the reference system which we are using in mechanics, that's called as Cartesian coordinate system. So we will use simply the Cartesian coordinate system to locate any body. So I'm telling you that this is the body. We are locating this body with respect to the Cartesian coordinate system. Now this body is changing its position. So if it is changing its position with respect to time, that means the time is also varying here. Okay, if the time is varying, that means we have to measure the time also. So in mechanics, for the measurement of time, we will be using simply the clock from today onwards. Okay. So this was all about a brief introduction about kinematics, what kinematics term means, and what we have to study related to kinematics. Now coming on to the motion, if as we all know, the motion will not be by itself only. The motion will be only there if there will be some sort of external force. So here the cause of the motion, it's simply the force. But in kinematics, we will not be discussing about any cause of motion. We'll be only discussing about the mathematics related to motion. Suppose on this body, I'm applying some sort of force. After applying some sort of force, it will displace from its own position. After displacement, there will be some sort of velocity, acceleration, etc, etc. These velocity, displacement, acceleration, these are all called as the parameters of force, which we will discuss in this chapter in whole detail. But the force which is causing these parameters, we will not discuss any force here in kinematics. We will discuss all the causes or all the forces in the chapter, that's known as dynamics. It's also the branch of the mechanics which will be dealing with the motion of the bodies, but here we will consider the cause of the motion, and in kinematics we will not consider any cause of the motion. Okay. So before starting the chapter, I'll revise the concept of position vector, as we all have discussed the same in the chapter vectors. So what this position vector means, suppose I'm having a body, and for the body, I know that the reference system I'm using, that's the Cartesian coordinate system. Now I need to locate the body in this reference system. So what I will do, I'll simply direct a vector from the origin to the body. The vector which I have directed from the origin to the body, this vector is simply called as position vector. Suppose I'm giving it as a name as R1. So position vector simply means a vector which we use to locate any body with respect to Cartesian coordinate system. Now after that, I'm coming on the very first topic of the mechanics, that's called as distance and displacement. Now, first of all, we'll explain what distance and displacement means. I'm taking a body that's at point A. I'm locating a body using the concept of position vectors. Suppose the position vector for body at point A is R1. Now the body is changing its position. After time t, it's coming at another position that's at point B, suppose. Now, locating the same using the another position vector, that is R2. Now, I'm telling that the body has changed its position from A point to B point. The change of position from A point to B point, or I can say this is the initial position of the body, and this is the final position of the body. The change of position of the body from initial to final position, this will be simply called as displacement. So displacement, we can write it as change in position vector, that is R2 final position minus initial position, R2 minus R1. And one more important thing, that the displacement is directed from A point to B point only when the body is changing from point A to point B. When the body is changing its position from point A to point B, I can say it's displacing something. So what sort of displacement is here? That will be simply equivalent to the change in position vector, that's R2 minus R1. Now, how I can relate the concept of distance with the displacement? So suppose the body is starting from the point A and it's going in this manner up to point B. The path is like this. So here the distance simply means the actual path traveled by the body. So if I'm having here the two paths, this is the first path from going from point A to point B. This is the second path from point A to point B. Now, what it means that I'm telling you that distance is the actual path traveled between the initial position to the final position. I can say the path first and path second, both are distances. But the second one is the special type of distance, that's the shortest distance between the initial and final position. This shortest distance between initial and final position is called as displacement. Now, this distance, it's not having any particular direction. It can go in any direction. It's path independent, so that means it's a scalar. But the displacement is having a particular direction from initial to final position. That means it's a vector. So we'll summarize some points between the distance and displacement. I'll repeat the same concept. So distance simply means the actual path traveled by a body, and the displacement means the shortest path between the initial and final position, or the change of position vector between the initial and final position. So I'll summarize some important points between the distance and displacement. Afterwards, we'll discuss some problems relating the same. So first of all, distance is the actual path traveled by the body. Actual path traveled by the body. And displacement is the shortest path between initial position and final position. Okay, or I can say displacement is simply equivalent to the change in position vectors. The second point, it's a scalar quantity, and as it's not having a particular direction, it's a scalar quantity. On the other hand, it's having a particular direction, that is, it's a vector quantity. As in the previous example, we have seen the both parts were called as distance, but the shortest path that was called as displacement. From there, we can derive here that the displacement will be equal to distance only in a straight path. But in other words, if the path is not straight, displacement will be always less than means. The magnitude of displacement will be always less than or equivalent to distance. So if it is a straight path, then the displacement and distance are all equal, as we have seen. So this was all about the kinematics introduction and the concept of distance and displacement. Now in the other video, we'll be discussing some of the important problems relating the same from the 0 level to the advanced level. Thank you.